Welcome to Chapter 1, Section 11, the HashLib module. In this module, we'll talk about hashing with Python. By the end of this lesson, you should be able to import and use Python's HashLib module, generate different types of hashes such as MD5, SHA-1, SHA-256, and SHA-512, and understand that the same input into a hashing algorithm always produces the same hash. Hashing is vital to cybersecurity because it helps maintain the CIA triad: confidentiality, integrity, and availability. Integrity is preserved by detecting any alteration to data, while confidentiality is supported by storing only passwords hashes instead of plain text. Availability is enhanced because hashes allow quick verification of data. In practice, hashes are used for verifying files, authenticating messages, and protecting credentials. Python's HashLib module provides multiple hashing functions. MD5 and SHA-1 are no longer secure, but still found in legacy systems and frequently used for file integrity checking. SHA-256 and SHA-512 are strong and commonly used in security applications. Remember, before hashing, text must be converted to bytes with encode, and the resulting hash can be returned in a readable hexadecimal form with hex digest. Here's a simple Python example. The user inputs some text which is encoded into bytes. Then the hashes are generated using MD5, SHA-1, SHA-256, and SHA-512. Each of these hashes are printed as hexadecimal strings, so it's easy to read. Let's go ahead and jump in and take a look at how we would write this example. I'm going to jump into Kali. And let's go ahead and create a new file and call this testing hashes.py. We'll just save that in the same directory for now. And the first thing we want to do is import HashLib. Now, once we import HashLib, we're going to prompt the user for the text to hash. Text equals input, enter string to hash. The next thing we want to do is convert that to bytes. So we're going to call this data, create a variable, and we'll just do text encode. This will encode to bytes, and then we can print the various hashes. So we'll print the MD5. So I'm going to use an F string here, and we'll do MD5 colon, and I'll use curly braces for a placeholder, and then we can call hash lib.md5, and we pass in the data that we want the MD5 sum, and then we call the hex digest to print it as a hexadecimal string. Let's go ahead and save this and test it. We'll jump into the terminal here and use Python 3 to run testing hashes. We'll enter in some string that might be used as a password, and we see we have a problem here. I used MD5 caps and it's lowercase, so let's go fix that real quick. It's an easy fix. Save that. We'll run this. And you can see that is the MD5 sum for password. Now, let's go ahead and check that. So I'll use MD5 sum. And what we're going to do is let's just do echo password. And we want to use no end line on the echo. So we'll use the -E or -N option for no end line. We'll echo that. We'll pipe that to MD5 sum. And you can see we get the same hash. All right, so the hashing's working. Let's go ahead and grab the other hashes. So I'll jump back to my code. And we'll change this to SHA-1. And this will be SHA-1. And I'm going to copy this real quick. And we'll do SHA-256 and 512. Save this. Let's go rerun our script. And you can see here are all the hashes. So the MD5, the SHA-1, SHA-256, and the SHA-512. We can even test this. We can do SHA-256 sum. So we'll do the same thing. We'll echo a string password and we'll echo that to SHA-256 sum. And you can see these two hashes match. So when we enter a string into a hashing algorithm, we always get the same hash as the result. That's how we can use these hashes for passwords. Now, hashing is a one-way encryption. You can't you can't take the hash and find the value of the string that was passed to the hash. That's why it makes it very useful for encrypting passwords and storing passwords at rest. For you, I have a coding challenge. In cybersecurity, verifying the integrity of files is critical for detecting tampering or corruption. One common method is to compare the file's calculated SHA-256 hash against a known good hash, often provided by the software vendor. Your challenge is to write a Python program that prompts the user to enter the path to a file, prompts the user to enter a SHA-256 hash string to validate against, reads the file in binary mode and calculates its SHA-256 hash, compares the calculated hash with the user provided hash, and prints whether the file is valid or tampered with. Good luck on this challenge. In the next lecture, we'll talk about file operations.